All right, hey everybody, welcome back. So we're going to wrap up our steganography lab today. We're going to look at not just picture embedding, but embedding text. I didn't get a lot of questions on activity 3, so hopefully that went well. Again, if you have questions, by all means, try to use the discussion thread in the assignment. I don't think I need to post a separate questions posted in Google Classroom, or you can email me or put a private comment in there in your document, whatever works. But again, if you have questions, feel free to reach out. But you do have the solutions and you have the teacher guide to kind of look at it. If we look quickly at our planning guide here, you're going to wrap this up where we wrap up our steganography, so that the 4th activity. And then next week, you're going to have the assessment component where you're going to be asked to answer some questions. And then you'll have to create your own kind of performance task for this piece. And then that's it. Then we'll see where we're at and probably get into our search and sort stuff and go from there. All right, so I'm going to talk through activity 4. And then if you again have questions, feel free to reach out. All right, so the way this is going to work is, again, we're looking at not just images, but text messages. And so the 4th activity is the same kind of ideas as before, but you're going to look at text. So we've talked before in different classes, this one included, about how we use the ASCII table to take a binary signal and basically map it to the alphabet, and then we get our text components. We're going to use that idea, but we're not going to use the actual ASCII table representation. We're just going to use the simple numbers for the alphabet to get through this. So when we go through it, basically we're going to look at how if we were to take, in this case, wrong pen, right? We're going to take just 1 being A, capital A, and then we're going to have a space at 27, and then 0 is just going to be at the end. We're going to see that that's going to give us the spacing that we need in terms of bits. So we can get 28 different integer values that we map to the alphabet. And we're going to use substrings in a second to basically come back and figure that out. So we know that we have 2 to our number of bits is our storage. And so when we do that, we're going to figure out that we need 5 bits is going to hold the values 0 to 31. So we have some extra bits at the end if we needed to. So we're going to use a 5-bit system to do this, and now we need to think about how we're going to free up space and then put those values down there. All right, so you're going to be given these methods, so you don't need to write them on your own or figure out. You just need to understand how they work. So what we see here is that we're being given back an array list of integers. Hold on a second. So this array list of integers comes back. One thing to remember with array list is you have to import it, and it takes an object, so you can't give it ints, you have to give it integers, but it's going to work the same way with auto boxing and unboxing. So we pass it a string. We make it uppercase because we're only going to worry about the uppercase. We're not going to worry about lowercase values. And then we basically make a blank array list of integers. Now we're going to loop through the string. We're going to pull a substring out. And then we see that if it's a space, then we're going to add the 27 to the result. And then down here, we're basically going to use index of. So we're going to take our capital, we're going to take our alphabet, and we want to know the index of the substring, right? So we have that substring value there. Now we're adding 1 to it because we want A to start with 1 and not 0. And so we go through here and we just pull the substring out, get the index of, and then that is the component that we have. All right, so it's going to allow us to encode, and then you return it at the end. All right, we'd also need to be able to go back the other way. And so when we have this, we see that, again, it gives us some method headers up here of what we're looking at. So 1 to 26 is A through Z, 27 is space. And then, again, we're going to be given an array list of integer codes, something that we would have just seen in the previous method. And we want to return a string. All right, so we basically go the other way. So we have an empty string to start. You have your alphabet. You're going to loop through the codes that you've been given. And again, codes.size, as it's an array list, it's not a length. And if it's a 27, we know that it's a space. Otherwise, we want to get this substring, right? So we're going to get those values again for an array list as a get, all right? So we get a substring, and then we basically pull out the value that we want from here, and that will give us back what we've coded. So we have the number that corresponds to the letter, and then we can build the string that we just had. All right. To actually put it in a picture, all right, we're going to need to basically break it up into 2-bit pairs, because if you can remember what our general method is, right? If we have an 8-bit sequence, 1, 2, 3, 4, 5, 6, 7, 8, right? We want to clear those low bits, and then we want to place our values there. So that is where we're going to put, we're going to take our RGB values, and we're going to clear those low values, and we can put our 5 bits there. Now, if we think about it, right, we need our 5 bits. We're going to have our RGB, so RGB, and we're going to clear the low bits, right? We are using 5 bits for our alphabet, and we've cleared up 6 bits. And so we need to think about what we do with that 6th bit. We don't use it for storage, but we have to have it. Otherwise, we're going to we need to think about those. So they have it in there about kind of how you can set that, but that's where that comes from. That we're clearing the low bits for the last 2-3 times, and that gives us that extra bit to deal with. All right, so now it's your turn. You're going to try to create this method that hides the text, and you're going to add these methods to the Steganography class. So you're going to add the hide text. So you have a source picture, and then you have a string, and then you want to be able to return it. Again, these are you can get lost in the weeds with this pretty easily. I want to make sure that you're just understanding the concept with this. If you need to look at the solutions, then that's fine. But again, give it a shot. You should understand the process of kind of what we're doing here. And again, this is a lossy transformation, but for the human perception, we're not gonna notice anything different. So after this one, you should wrap up your Steganography lab. Make sure that that's submitted. And also, if you haven't submitted your picture lab, make sure that you do that as well. I'm going to be looking through those in the next couple of days and putting some grades in the gradebook for those. All right. Good luck with everything. And then again, if you have questions, feel free to reach out.